All right. In the absence of questions, and the quiz for chapter 34 is established, let's talk about refraction. Two big characteristics of light are that it reflects and it refracts. So when light goes from one medium to another, such as air to glass or something like that, it will bend. Assuming that most of you at some point in your life have seen a pencil in a glass of water and you see how the pencil is not in a straight shape. That's because of refraction. So let us explore that. So we'll call this 1 and 2, or probably easier, A and B. So these are two different medium. You can think of this as air and glass if you want to, but it's some medium and it's two different medium. Two different media. And so as light's coming in, it's going to hit the boundary here and it's going to not go in a straight line, but it will do something like that. In terms of angles, we have the angle of incidence and the angle of refraction. Unfortunately, refraction and reflection start with the same letter. Let's see if I used a different letter here. Theta 1 and theta 2. I'll stick with theta I and theta R for right now. We've established that light travels in waves. So this actually can be described by the wave part of the wave property of light. And so it's coming in with a certain frequency. It's going to hit here. So it is. So think about what is frequency?
Cycles per second.
So if I have, 5 cycles a second coming in, it's going to hit the boundary and it's going to be 5 cycles a second afterwards also. The number of cycles per second doesn't change just because it enters a new medium. So if I have 5 cycles every second hitting this point, I'm going to have 5 cycles every second hitting that point, regardless of what else happens. So my frequency up here should be equal to the frequency down below. And that's the common thing that we're going to be exploiting. We do a little geometry here. It's traveling at some speed v. And then afterwards it's traveling at a different speed. And ultimately we're going to be looking at that relationship there. I want to pick a certain distance here, so if light is traveling, so if it takes a certain amount of time to travel from here to here, this distance would be VIT. Or I keep flipping back between I and A here. I'm going to call it VAT. In the same amount of time over here, it's going to travel VBT. Whatever the speed is in medium B times time. If I set up some triangles here, so let's see, I got my line right here where this length is VAT. This is VBT. So just redrawing, try to simplify it some, or make it a little less cluttered. I should have drawn that line first. So I'm going to basically set up a right triangle here. And that's supposed to be VBT also. So I'm setting up two right triangles. This angle right here, this theta sub, I'm going to switch over to theta sub A. And then down here we have this theta sub B. Well, this right here, this is a vertical line. This line right here is perpendicular to my flat edge right here. So highlighting that contrast there, that is a right angle there. So therefore, this angle right here must be the complement of A, which I will label as theta A prime. So formally, theta A plus theta A prime is equal to 90 degrees. Which says that this angle over here has to be equal to theta sub A. This is the complement of that. This is the complement of this. Because I got the right triangle here. So this is theta sub A. Through similar logic, we can come up with this angle right here is theta sub B. Now what I have in common between these two triangles here is they're both right triangles, but also this length from here to here is the same for both of them. So let's set up a little trig relationship here. We'll call this H, for lack of anything better. What trig function associates this angle with that side and this side?
Sine.
So the sine of theta A is equal to VAT over H. What about the relationship between this side and this side? And that angle?
Cosine.
What would cosine be? What is cosine?
Opposite over hypotenuse.
Cosine is adjacent.
Tangent.
Pardon?
Tangent.
What's the definition of tangent?
Opposite over adjacent.
Yep. This is still the hypotenuse here.
Okay.
What are we left with?
Sine.
Sine again. Yeah, it's the opposite over the hypotenuse. So this would be equal to VBT over H, which is the sine of theta B. Oops, that's bad notation there. So H is equal to VAT sine of theta A, which equals VBT sine of theta B. So time cancels out. So I'm left with this relationship here. And so we can write this as VA over VB. So bring that over this side, bring this over here, is the sine of theta B over the sine of theta A. Take it one step further. The speed of light in a vacuum is c. This is speed of light in a vacuum. But as it travels through a medium, it really doesn't travel that fast. I think we've talked about before the fact that they got down to what, 6 meters per second. Okay, I did mention that in here. So the actual speed is v, and so they made up this thing called n, which is just the speed of light divided by the actual speed of its going through a medium. So this is speed of light, the net speed of light in a medium. So therefore, the speed is equal to c divided by n. So coming over here, this becomes c over n sub a over c over n sub b is equal to sine theta b over sine theta a. And that would be n sub b over n sub a. And I had something backwards here. What did I mess up? So n is c over a. All right, I'm good with that. Flip it across the diagonal. Good with that.
Is there order?
Okay, stop.
That
Sorry.
equation?
Say it again.
Because when you simplify that equation, hypotenuse equals whatever, VA over VB equals sine theta B over sine theta A. When you cross multiply, is that what you're supposed to get?
Yeah,
I guess I don't get that breakdown.
get this one?
Yeah.
Well, part of the issue is this line here is long, so
Okay.
let's go back to there. All right, so h is not equal to that times that. H is equal to cross multiply. So this is VAT over sine of theta A from here. And then from here, it would be VBT over sine of theta B. So h is equal to both of those. We can cancel out this time, since I established earlier that it's the same amount of time. It's how we were looking at how far did the light travel in a certain amount of time. And then, so the next, so we have VA sine theta B cross multiplying is equal to VB sine theta A. Now we bring in what I have over there. So this becomes speed of light over n sub A sine theta B is equal to the speed of light in a vacuum over this n sub B sine theta A. So if two fractions equal to each other, or two things equal to each other, cancel out common factors. So I'm left with sine theta B over n sub A equals sine theta A over n sub B. And now cross multiply again, put it in a more common form. N sub B sine theta B equals n sub A sine theta A. This n has a special name. This is known as the index of refraction. And this relationship right here is known as Snell's law. I guess it should be a capitalized S. And that is the essence of the next 2 chapters. All right, so as an example, if this is air and glass, index of refraction of air is approximately equal to 1. Index of refraction of glass is approximately 1.3. So the kind of glass, oh, no, sorry, 1.3 is water. Glass, depending upon the type, 1.5 to 1.63, so why don't we just go with 1.5, 1.52. If light is coming in at an angle of 30 degrees from the normal, what angle will it travel in the glass? So we have n sub 1 sine theta 1 equals n sub 2 sine theta 2. And so this becomes 1 times sine of 30 degrees is equal to 1.52 times the sine of theta 2. Sine of 30 degrees is a half, so this becomes 0.5 over 1.52 is equal to sine of theta 2. And so theta 2, the angle at which it's traveling here, theta 2, would be the arc sine of 0.5 over 1.52, which is something absolutely spectacular. If someone would be kind enough.
What do you mean by arc sine?
Is that inverse sine?
Inverse sine.
Oh.
I guess arc sine's the more archaic.
Yeah,
It's-
it was.
Arc sine is what I was taught, so
Should we be in degrees or radians?
since that's
Degrees.
that doesn't really matter. Yeah, degrees probably be easier.
We got 19.20 degrees.
Do we have confirmation on that?
Yes.
So, yeah.
All right. So that means if it's coming in at 30 degrees, it's going to be coming out at 19.2 degrees as it enters the new medium. Well, let's take it that next step. We send it through a plate of glass. Coming in at 30 degrees, this is air, and glass, and crown glass. Now they do talk about the different index of refraction for crown glass, for flint glass. I actually have no idea what the difference is. Anybody in here know what the difference between crown glass and flint glass is? This was not the language of my childhood. It was glass.
Yeah.
Don't break it. That was generally the follow-up. So if this is coming in at a 30-degree angle, it's gonna be then going through the glass at a 19-degree angle, 19.2 degree angle. When it gets to air again, what is going to happen? Well, it should bend away from it because it's a lower index of refraction. We'll call this theta 3. What is that angle there? We have going from here to here. So we have in 1.52 times the sine of 19.2 degrees is equal to 1 times the sine of theta 3. So theta 3 is equal to the arc sine of 1.52 sine of 19.2 degrees. Which was the original angle of incidence. So if this is 30 degrees here, that red dotted line just an extension of what we originally started with. This difference between where the light was coming in and where it actually ends up coming out should be related to just the thickness of the glass here. Let's see if I can draw this a little bit more neatly. Draw a normal. 30 degrees, it's roughly like this. So light's coming in here at our 30-degree angle. That's the path the light would have taken had it not had the glass in between. Then it shoots down at 19-degree angle, 19.2 degrees. And then so the question is, what is that as it relates to the thickness? I'm using T for time earlier. I'm just going to reuse T. This T stands for thickness. And this will just use D for distance. In essence, we're trying to find that distance right there. That's a right angle. Let's see, what do we know? I know that that's 30 degrees there. Therefore, this right here has to be 60 degrees. Therefore, this right here has to be 30 degrees. I'm assuming all of you have incredibly good vision. Let's see, I know that this angle right here is, well, whatever the complement of 19.2 is, 70.8 degrees. Because looking at this right triangle here, looking at that triangle. I know that this angle here has to be 30 degrees because I've got the two lines that cross right that and the, not alternate interior, the, blanking on the geometry vocabulary. You have two things like that angle and that angle are the same. Anyone recall what that's called?
I feel like it starts with a C.
Congruent?
Converted?
Congruent?
Congruent? They are congruent, but there's a special, those angles are congruent, whatever the,
They're equal.
yeah, all right, they're congruent angles. So this angle and this angle are congruent because I have two straight lines crossing each other. So that's 30 degrees there, so I can figure out that angle there, well, it's whatever 30 minus 19.2 is. So this is 30 degrees minus 19.2 degrees, which is 10.8 degrees. Actually, do I need that? I don't think I need that. Let's take a look at this triangle right here. This is the 30-degree angle here. I'm looking at this triangle right here. That's 30 degrees there. This is some thickness t, and I want to figure out what is that distance. In other words, from here to here. What is that distance? Or how would you find it? If you know t, how would you find that?
Tangent?
Yeah. What do we call this? Something clever like x. So the tangent of 30 degrees is equal to the opposite over the opposite over the adjacent. So x is just going to be t times the tangent of 30 degrees. So this is the thickness times the tangent of 30 degrees. If I look at the skinnier triangle, where this is 19.2 degrees and this is the thickness, what would that do? So I'm looking at this distance right here.
It'd be the same, just with 19.2.
So this is t times the tangent of 19.2 degrees. And I'll call that y. So looking at the other triangle here, this distance right here, it's just got to be the difference between the two. So that would be the thickness times the tangent of 30 degrees minus tangent times the, t, thickness times the tangent of 19.2 degrees. I can now look at the smaller triangle here. Where that is 30 degrees there, and that is 60 degrees there. This distance right here is the thickness times the tangent of 30 degrees minus the tangent of 19.2 degrees. And this is what I'm trying to find right here. This distance between here. So given this right triangle, what is this? What I've labeled as D.
Would be t times your tangent of 90 degrees.
T times tangent of 90 degrees, is that what you said?
Mm-hmm.
Tangent of 90 degrees is undefined or infinite, depending on how you want to look at it.
So it's not that.
not that.
Okay.
So given this triangle right here, which one's the hypotenuse?
Top one. Top line.
Okay, that's my hypotenuse. All right, so I know the hypotenuse here. I have some formula here for the hypotenuse. And I have this side right here. I don't have both small sides, so tangent's probably not the way to go for this last bit.
You can use sine or cosine.
Okay, which one do you want to use?
Sine.
Okay. So since this sine is opposite and this is opposite the 60 degrees, so we have sine of 60 degrees is equal to d over the thickness times tangent of 30 degrees minus tangent of 19.2 degrees. And so the thickness, or I guess I was looking for a relationship between thickness and that distance right there. So solve for thickness is going to be equal to the distance between them divided by sine of 60 degrees times tangent of 30 degrees minus tangent of 19.2 degrees. So let's make this distance 1 centimeter. So this becomes 1 centimeter divided by sine of 60 degrees. Probably easier on a calculator at this point. And square root of 3 over 2. This is square root of 3 over square root of 3. And I don't know what 19.2 is, so.
Yeah, 5.04.
For the final thing? Centimeter.